A little note about these. This is a new subscript. I don't think I've used it yet. Does anybody know what the 0 means? I probably said it early on. What is it? It's initial. It really means at t equals 0. So it's like a 0 for at 0 time. And so we'll use that for initial from here on out. That's sort of the normal thing to use. This can also be replaced with either x or y. So when we're talking about a horizontal motion, we use x. When we're talking about vertical motion, we use y. All right, let's do some problems. And you have lots of problems in the homework to practice too. You will just have some calculation type problems to do. Let's look at this. This is an auto race. So I want to think about a couple of things. Let me just write that down. This was our maximum speed, v, was 132.3 miles per hour. I'm going to go ahead and convert that into meters per second. I'll let you do that on your own. I'll just give you the value, but it's 59.14 meters per second. So this is his speed. When I write it without a subscript, that is like the final speed. So before we did VF, but now I'm just going to write V. V naught, gosh, what is the initial speed of these cars? Right, they're all 0. Often your initial speed will be 0, and in this case that's true. 0 meters per second. And then we know a couple other things. We know that x, the distance that they travel, that's equal to 1/4 of a mile. Let's see, there are 1609 meters in a mile, so that gives us 402.3 meters. And I want to know a couple of things. I want to know what is the acceleration. I just want to know what is the acceleration, and then we're going to come back and make another calculation. So I also know the time that he traveled this in. He gave it on the screen. It was 10.8 seconds. So whenever you're working through these kinematics problems, we'll work through some old test problems in just a bit, but whenever you're working through these old kinematics problems, you want to develop the skill to be able to read the problems and figure out what is the information that's given and then what is the information that's needed. And that sounds easy, but in practice it's not really terribly easy. Some of your quiz questions are that way, actually. A lot of your quiz questions are that way, where you need to be able to read the problem and then figure out what it is that you know and what it is that you don't know. And then you need to be able to go to those two kinematics equations, and you just need to memorize these. The two kinematics equations, v equals v naught plus at, and then x equals v naught t plus 1/2 at squared. Here I've left off x naught because x naught, it'll always be 0 as far as we're concerned. That's your initial position. So I'll write it this without the x naught.
Do we not have to write it on the test?
No. Then you want to be able to look at these equations and say, well, gosh, I'm looking for the acceleration. It's here or here. And then figure out which of these equations can you use, which has maybe only one unknown, or how can I find that unknown for the acceleration with which of these equations. Or in some cases, you'll need to use both. You'll have to do some substitution of one equation to the other. Okie dokie? You with me so far? Which would I use, the top one or the bottom one? Right, the top one, because I know v naught, and I know t. So I'll solve that for the acceleration. They do give you x, and you could use the bottom one because you know x. Yeah, you could use either one, but we're going to use this one right here. All right. So v is equal to 59.14. Actually, I'm going to solve this just for the variable first, for a. So a is going to be v minus v naught divided by t, but v naught here is 0, and so it's just going to be v, which is 59.14, divided by 10.8. Then meters per second, seconds, just check my units for a quick little check. It is meters per second squared, and that gives me an acceleration of 5.48 meters per second squared. Check my sig figs. I have all the right sig figs. I'm limited by the 10.8 seconds to 3 sig figs. Just a little answer our little note here that on the test you will have some questions specifically about significant figures, but all the other questions, like from chapter 2, for example, there won't be answers that are only distinguishable by significant figures. You understand what I'm saying? Like, I'm not going to give you the same number but with 3 or 4 sig figs, and you have to pick that out. Okay? But I will give the answer in proper sig figs. All right, so the acceleration is 5.48 meters per second squared. Now next I want to figure out what is the displacement. Now I know that we already know what is the displacement, but just bear with me, and I want to illustrate something with this. How would you figure out the displacement? Let's say that we did not know this. How would you find the displacement? Would you use the top or the bottom? Bottom. And you know everything in this, right? We know v naught, we know t, we know the acceleration now because we just calculated it. And so now I can find out what is x. So x is equal to v naught t. It's 1/2 a t squared. That's equal to 0 times t, so that just goes away, becomes 0, plus 1/2 a, it's 5.48, times t squared, which is 10.8 seconds squared. And when I solve that, a funny thing happens. I get a value equal to 319.6 meters. It's funny because, remember, we know the length of the track. This is a 1/4 mile track. And the length of the track is actually 400 meters, roughly 402.3 meters. So, what gives? Like, what about the way we've approached this problem is incorrect or is not really complete? Okay. Right. So it takes a as Brennan said, it takes a little while to get up to that 5.48 meters per second squared acceleration. Let me take a little aside and tell you something. Just a quick little aside, and then we'll come back to it. Remember, if I have an x versus t graph, the slope of this equals the velocity, right? If I have a v versus t graph, the slope of this equals what? Acceleration, right? This is saying that the derivative of velocity with respect to time, that is the acceleration. The derivative is the slope. However, what does the area under this graph give us? And this is something that you need to know, because I will give you some v versus t graphs and ask you what the area means, or ask you to calculate a certain value that you'll need from the area. So what does the area under a v versus t graph tell us? Don't answer just yet. Just think for a second. Let everybody think. Think about what are the units of a v versus t graph. And then the units of your v versus t graph, the area, should tell you what your area is. So how do you find area? Base times height, right? Base times height. So I'm taking the units of this times the units of that. What's the units of this? You can answer that. Meters per second. The units of v are meters per second. T is seconds. And so the units of the area are what? Just meters, not meters per second squared. That's the units of the slope, which is rise over the run. But the units of the area, meters. Okay? So what does the area give us? Distance or displacement. It gives us the distance traveled. So the area equals x. So if I were to plot my v versus t graph, this is the point of all this. If I were to plot the v versus t graph, it would look like this. It would have a slope equal to Or what should my slope be? No, not 132.3. 5.48 meters per second squared. It should have an area underneath it, as we've calculated it anyway. The area of this graph will be what? 319.6 meters. So this shows a car that is constantly accelerating at 5.48 meters per second squared with an area of 319.6 meters. Now, we know that they actually travel like 400 some odd meters. So what is the actual line going to look like for this? It's not going to be a straight line. Is it going to be a line that comes above this red line, or is it going to be a line that comes below it? How far did they actually travel? 400 meters, which is a value that's bigger than 319, right? So that means that the area that they travel has to be more than that blue hatched area. Correct? Am I right in thinking that? Yeah? I am right actually. But so that means that I have to have more area under the curve than what's shown here. So actually it's going to look like this. I like this line. You're going to like this. Watch this. It's going to look like that. So, because this area will now be bigger, it'll be, 402 meters. So actually it looks like not that they have a slower acceleration, but they start out with a faster acceleration. And coming off the block, I don't have cars, but coming off, they seem to accelerate at a faster rate. But as they go faster and faster, it becomes more and more difficult to keep increasing at the same rate. And we'll see that when we get into chapter 5, that the faster you go, the harder it is to go faster. It's generally true for your cars. Okie dokie? We're going to do some more problems, but I like this one because the graphing is important. This whole part about the area being the displacement of a v versus t. The slope is the velocity of an x versus t. And the slope of a v versus t is the acceleration. Let's see. Let's do a few quicker questions. Y'all doing great on the quiz so far, by the way. The one that's due tonight, I guess. I know it's a little overwhelming. This quiz is a little more difficult than the one last week. Is that true? Yeah. But y'all are doing great. The averages in this class are very high. Very proud of you. We've done some of these. If you have your workbook, it's in the back. We've done this one, right? Does anybody know how far we stopped here. Okay, you drive for 30 minutes at 30 miles an hour, and then another 30 minutes at 50 miles an hour. What is your average speed for the whole trip? Remember, let's go back, y'all go back to your definition for what is average speed or average velocity one here. What is your average speed for the whole trip? I'll stop at 110. 110. Feel free to ask your neighbor if you're not sure. I'll go to 115. 115. 115. Okay, good. B is right. You can check this. You can ask, well, gosh, how far do they go? 30 minutes at 30 miles an hour? How far are you going to go in half an hour at 30 miles an hour? You go 15 miles. 30 minutes at 50 miles an hour, you go 25. So I go 15 miles, I go 25 miles. That's a total of 40 miles in two 30-minute segments. So in 1 hour, that means that I go 40 miles in 1 hour. Delta x over delta t is 40 miles per hour. Or you could say, because these two time intervals are the same, 30 minutes here and 30 minutes here, I can just say 30 plus 50 divided by 2 gives me 80. And that's okay too. But I always find it's best to return back to our definition for average velocity. You drive 4 miles at 30 miles per hour, and then another 4 miles at 50 miles per hour. What is your average speed for the whole 8-mile trip? You can calculate it, but try thinking about it too. Think about how long I'm traveling at each speed and how that affects my overall average velocity. I'll stop at 110. 110. So your answer in. You have 5 seconds. Even if you're not certain, just click in. Remember with the clicker questions, if you get it wrong, not a big deal. C is right though. Good job, those 57 of you. Couple ways you can go about this. The easiest way is to say, gosh, I travel 4 miles at 30 miles an hour, 4 miles at 50 miles an hour. I'm traveling longer at 30 or 50. Right? It takes me longer to drive 4 miles at 30 miles an hour than at 50 miles an hour. So I'm traveling longer at the slower speed. That means that the average is going to be less than the average of 30 and 50. Or if you want to do this the brute force method, that's okay too. You could just calculate delta x and delta t. So I'd say v equals delta x over delta t. Delta x is 8 miles divided by delta t. And then you would have to say, well, that's t. You'd have t1 is equal to 4 divided by 30. That's 4 miles over 30 miles per hour. And then you have to do the same for t2. It'd be 4 divided by 30 plus, what, 4 divided by 50. And that's going to give you some value that will be less than 40. I don't know what that value is, but it'll be less than 40. That's sort of the brute force method. Figure out the total distance, figure out the total time. Some of y'all did it this way, right? So you might know the value that it comes out to be. It's okay if you do it this way. It just takes longer. No, it doesn't matter. It's less than 40. All right, if the velocity of a car is non-zero, can the acceleration of the car be 0? Oh. If y'all get above 90% on this one, I'm going to give you very exciting news. Very exciting news. If you have to get more than 90%, you're almost there. All right, I'll stop at 35. 35. What is it? Does somebody know the exciting news? Oh. Awesome. Look at that. You ready for the exciting news? Test 1 week from Wednesday. Wow. I'm serious. All right? It's your opportunity to excel. Okay? I just want you to keep that on your horizon because 1 week from Wednesday, we have Monday off, then Wednesday and Friday, and then Monday, and then we'll come in and we'll have the exam. Okay? All right. Huh? You got exciting news instead.
What's the exciting news that you
Okay, well this is kind of a middle school joke, so don't shoot the messenger. Knock knock. Smell mop. No thank. You'll get it later when you think about it a little bit. All right. When throwing a ball straight up, which of the following is true about its velocity and its acceleration at the highest point in its path? When you throw it straight up like this, what's true about its velocity and its acceleration? You might not know this right off. We're going to cover it in the next section, but I think you can think about it to get the answer. I'm going to stop at 58. 58. Hmm? All right. C is right. What? 57 of you. Who are those 57 students? They're all changing around. Listen, if you feel like you're always getting the questions wrong, you know what? Somebody else is always getting them wrong too. Don't sweat it. Just no, I'm serious. I'm serious. Like you're not alone. Look at this. There's a lot of people that aren't getting them right. So don't sweat it. Just keep doing your homework. Keep practicing. Come see me if you need help. Go to the tutoring center if you need help. We're early in the course. Nobody's lost yet. Okay, so what was the answer? C? So if you throw something up in the air, at the top, it seems clear that the velocity goes to 0, right? It stops. It goes up, it stops, and then it turns around and comes back down. Remember, the acceleration describes how the velocity changes, right? How does the velocity change? So what would happen if the acceleration went to 0 when it was at the top? It would what? It would just stay there. It would just, like it would go up because the velocity would be 0, and if the acceleration was also 0, it would just hover right there, okay? If the acceleration was actually 0. But in all cases, the acceleration is negative. The acceleration is always towards the Earth. So as it goes up, it slows down, and then as it comes down, it speeds up. And at the top, it changes direction. It goes from going in the positive direction up down to the negative direction. We'll talk about that more later. Oh, by the way, I think we have this. Let me see. Let's come back to this. Okay, so we're going to look at freely falling objects. So on Earth, objects fall with constant acceleration, and we call this g, the magnitude of this acceleration. Some of you might have learned that g is equal to 9.8 meters per second squared, but we're just going to round that off and make it equal to 10 meters per second squared. It makes life a whole lot easier when you're doing the math, and especially you MCAT students, like you'll need it to use it at 10 because 9.8 is just hard to work with. Also, as we said, the acceleration due to gravity is negative. It's in the negative direction or the downward direction. So whenever we talk about the acceleration due to gravity, I'll say that it's equal to negative g, which is equal to negative 10 meters per second squared. So it's just a little bit of, I don't know, nomenclature. that we're calling, g is the acceleration due to gravity. It has a value equal to 10. And we usually write this as a positive value. We'll see why that is in the next chapter. But when we're talking about the acceleration due to gravity, we'll write it as negative 10 because it's always in the downward direction. All right. And so in freefall problems, we want to consider several properties of the motion. Let's imagine that I have an object that I throw up, and then it goes up, and then it comes back down. So a couple of things I just want to point out about this. First of all, at the top of the trajectory, v top, this is equal to 0. It goes up, it stops, turns around, and comes back the other direction. So v top is equal to 0. As it's going up, the velocity is positive. As it's coming down, the velocity is negative. And the acceleration is always equal to minus 10 meters per second squared. Okay? Another thing, in this particular scenario, because it's going up the same distance as it is coming down, and because the acceleration is always at the same time, in this particular instance, because it's coming to the same point down here, t up will equal to t down. You follow what I'm saying? The same amount of time to go up is required to come down again. Also, sort of wrapped up in that, because it goes up in a certain amount of time, and then it takes that same amount of time to come back down again, the velocity at this point is going to be greater, less than, or equal to the velocity at this point. It's going to be equal. So whatever your velocity, or whatever your speed is at this point, will be equal to the speed here. Now they'll be in opposite directions, but they'll have the same magnitude. So if I call this v naught, and this v naught will equal to v. Or really, to be more correct, I'm going to put absolute value bars. What's that, William? Right before it hits the ground. We'll always talk about the speed here as being right before it hits the ground, and the speed here as being right before it leaves your hand, or it leaves whatever it is that's projecting it. All right, so that's a few things. V at the top is always 0. The acceleration is always minus 10. The time to go up is the time to go down, only in this case because y is the same up and down. We'll see some problems where we say we have something that goes up and then it comes back down like that. In that case, the time is not the same up and down. This is a much shorter time than over here because we're traveling a longer distance. All right, we're going to watch the Red Bull Stratos. Y'all know this? Y'all know what I'm talking about? The guy took a balloon up to space, and then he jumped out. Y'all know what I'm talking about? Yeah, I'll show you a picture. We saw the thing that he jumped out of. I'll send y'all a picture in one of my little weekly digests. Y'all like getting little pictures and stuff? Yeah. Okay. So I'll show you that. Let's just go and watch the video. Oh, for goodness sake. Are you serious? All right, so I was at t equal 21 seconds. This guy jumps out. I want to know how far is he fallen in this time. So we want to write down what we know. We know that v naught is equal to 0. I know that t is equal to 21 seconds. And I want to know what is y. Oh, I know something else, right? What do I know? I know the acceleration is equal to minus 10 meters per second squared. Acceleration. Is that? Yeah, we'll write it as acceleration. It's minus 10. Yeah, so I can either use v equals v naught plus at, but that doesn't tell me what y is. Or I can use y equals v naught t plus 1/2 at squared. We'll pick up there. I just want to remind you, I sent an email out. We are having lunch. It's over in the conference room if you want to join us in about 10 minutes or so. You need to memorize these two equations, okay? That's really the only equations you'll have. Okay. Yeah, y.